So now we will take the next problem. From the last lecture, we have seen the connected beam problem. So one more numerical we will take on that. So here find the reactions. Find the reactions of the beam shown below. Okay. So we need to find out the reactions of the beam which is given below. So I'm drawing the diagram now. So here, this is the first beam. And here one at point A, this is point A. Here the support is given at point A. So this is the support which is given at point A. After that, here another support is given at this point. Here this is a type of roller support. Okay, this is the symbol of showing roller support. I have already told you about this. This point is called as point E. Okay, this point is called as point E. They have given the name itself. Okay, otherwise you can take any name, no problem. Here is one inclined load. This load is inclined at an angle of 45 degree and this is 40 kilonewton. 40 kilonewton load is there and the angle of inclination, this angle, it is 45 degree. This is given as 45 degree. And then one vertical load is there which is of 20 kilonewton. It is acting like this, vertically downwards on this point E. And the value of this load is 20 kilonewton. 20 kilonewton. And to this beam now, another beam is connected. Okay. So the next beam I will draw, it will be like this. This is the another beam which is connected. It is like this. Okay, so this is the beam. Now the supports are given to this also. The support at point C, this is the support at point C which is provided. This first point, it is named as point C. This is my point C. Then here is one load which is inclined. Here it is inclined like this. This is inclined load. Okay. And the magnitude of this load, it is given as 20 kilonewton. And the angle of inclination is 60 degree. So this is 60 degree. This angle of inclination is 60 degree. Then here one more load below this point. Here is the load is given below this point and it is not load, it is support. Support is roller support. So the roller support is provided over here. This is the roller support. We will give the names. Let us call this as point B. This is point D. And after that, at this last point, just 1 minute. But okay. So at the last point here, there is a what we can say couple. So the load is given like this. See, it is given. So this type of loading is given. This is 10 kilonewton. This is also 10 kilonewton. And the distance between them is 0.5 meter. So the distance between them, this distance is 0.5 meter. Now I will give you all the distances. So the distance from A point to C point, Okay, the distance between these two, A to C, it is 1 meter. Okay. Then again, distance between C to E. So the distance between C to E, this distance is again 1 meter. This is also 1 meter. Then from E to D or B, you can say B and D, it is again 1 meter. And I think the distance is of this 60-degree course. Okay, so this distance is 1 meter. This is also 1 meter last distance. This is also 1 meter. I think the distance between E to D. Okay, E to D, it is given as 2 meter. This distance is not 1 meter. This is 2 meter. And I will check the distance of the point load. Just a moment. So this distance is 0.5 meter from C point to this. This is 0.5 meter. So now we need to solve this numerical. So first of all, we will draw the free body diagram. Okay. First of all, I will draw the diagram for beam AB. Okay, AB, top beam. So if I draw it, AB, this is AB. At point A, here is hinge support is given. So there are two reactions at point A. This is our point A. This is vertical reaction at A, VA, horizontal reaction at A, HA. Then at point E, here is the reaction at point E. This reaction is RE. Reaction at point E is RE, and this is vertical reaction roller, because roller is rest on horizontal surface. Then here is the load. This load is of 20 kilonewton, and again inclined load. This is the inclined load. This is of 40 kilonewton, and this angle, it is 45 degree. Okay, so we will call these points A. This is our point E, and this is the point B. Okay, so A to E distance, the total distance is 2 meter. A to E distance, this total distance is 2 meter. Okay, now I will not write the distances right now. So this is the given diagram first. This is for beam AB. Now if you think about this beam CD, now if I draw the free body diagram of beam CD, then it will be, this is the beam CD. Now at point C, again simple support is provided. So at point C, again hinge support is there. So vertical reaction and horizontal reaction, two components will be there. So this is the point C, vertical reaction at C and horizontal reaction at C. Then at point D, again roller support is there. So here at point D, which is nearly this below point B, at this point here, there is a reaction, vertical reaction RD. Vertical reaction RD. On this beam also, inclined load is there. So this is the load which is acting. This angle is 60 degree, and the magnitude of the load is 20 kilonewton. 20 kilonewton. And then this reaction RE, now if you see at this roller support, this reaction, whatever we are getting from this roller, it is connected at this point to beam AB. So it is shown vertically upward, but it is connected to this point, which is downward. okay, to beam CD. So it will act downward on beam CD. So here I will show same. This is the reaction RE again, which is acting on this beam. And then now here you can see lastly here, this forms a couple. Okay, you can see two equal unlike parallel forces. These two forces are equal, parallel unlike parallel, okay, separated by a definite distance of 0.5. These two forces forms a couple. Okay, so how to calculate the moment of a couple? Now if I want to calculate the moment of this couple, now I am talking about just this, I am talking about this only. Okay, this whatever given over here. Okay, I will highlight this. I am talking about this portion. Okay, this portion only. So you can see now this portion. I want to calculate the moment M, moment of a couple. I have already told you how to calculate the moment of a couple. Moment of couple is one of the force into lever arm. So here you can see 10 kilonewton is the magnitude of the force. So I will take one of the force 10 kilonewton into what is the lever arm? Lever arm is this 0.5. Distance is 0.5, 0.5. Okay. So M is equal to, it is 10 into 0.5. So it is 5 kilonewton meter. So this moment will act on this point. Okay, here it will act. But what is the direction of the moment? Now to find out the direction of the moment, see the arrow of both the forces. These are the arrows. So take the head of this arrow and rotate about the second arrow. So if I rotate this first arrow about the second, then it will rotate in this direction. And also this arrow, if I rotate, it will rotate in this direction. Okay, so the direction of rotation is like this. This is anti-clockwise. This is anti-clockwise. Okay. So here this is minus. Minus sign is anti-clockwise. So at this point here, I will show the anti-clockwise moment. Minus sign is there. So I will remove this minus sign by showing the moment in anti-clockwise direction. So this is the anti-clockwise moment. And what is the magnitude of the moment? It is 5 kilonewton meter. This minus sign is for the direction. Now once I show the corrected direction anti-clockwise, then there is no need to show the minus sign over here. Okay, मायनस साइन कशासाठी आहे तर मुवमेंट अँटी क्लॉकवाईज हे सांगायसाठी मायनस साइन आहे. मग मी तिचं काय केलं, मुवमेंट दाखवतानाच अँटी क्लॉकवाईज दाखवली आणि 5 किलोन्यूटन मीटर लिहिलं. ओके, सो दिस इज द फ्री बॉडी डायग्राम. एनी डाउट इन दिस? Free body. Okay, so this is the free body diagram of both the beams. Now what we will do now, first we will solve this beam AB. We will calculate the reactions at A and we will calculate the value of RE. And after getting the value of RE, we will solve this beam CD. Okay, I have to give the name to these points. This is my point D and this called it as point G. Okay, this end point is point G. Let us say that it is point G. So now first of all, I will consider beam AB. So here I will write consider beam AB. Now I am considering beam AB first. So here you can see in this beam AB, if I take the moment at A equal to 0, moment of all the forces at A equal to 0 here. If I take the moment at A equal to 0, then HA and VA 0. Now here you can see there is inclined force of 40 kilonewton. So we need to resolve that force first. So to resolve the force, I will draw one component parallel to y-axis, another component parallel to x-axis, such a way that your main resultant force will come in between these two forces. Okay, your main resultant force, this force will come in between these two forces. So now this angle is 45 degree. So which component is cos and which component is sine? Horizontal component you will give cos or vertical component?
Horizontal component cos.
Okay. So this horizontal component is 40 cos 45. Okay, and this vertical component is 40 sine 45. I think number of times we have resolved the forces, so there should not be any confusion for you. Okay, where to give the cos and where to give the sine. So now this is the resolution. Now here also you can see HA is passing through point A, VA is passing through point A, movement 0, then this 40 cos 45. If you extend the line of action of this 40 cos 45, it will also pass through point A. So its movement is also 0. So what is remaining? This 20 kilonewton. So the distance from A to E, this is the distance of 20 kilonewton. Now here we can see in this diagram, this is point A, here it is point E, A to C it is 1 meter, then again C to E it is 1 meter. So A to E total distance is 1 plus 1, 2 meters. So this total distance is 2 meter from A to E. So A to E the distance is 2 meters. So I will write 20 into 2. Okay. So here summation M about A equal to 0, that we are taking clockwise moments are plus, anti-clockwise moments are minus. So here it is 20 into 2, my first term, 20 into 2. Now this 20 kilonewton is moving downward. It is moving downward. Point A is here. So if I rotate it about point A, it will rotate in clockwise direction. So it is plus. Next is this RE. The distance of RE is also same. It is at a distance of 2 meter. But it is rotating in anti-clockwise direction because it is moving up. So take this RE upward and then rotate. So then you will get the direction. So upward and then rotate. So it is in anti-clockwise direction. So it is minus 2RE. Minus 2RE. Next is this. Now 40 we have resolved. So 40 cos 45 it is already 0. 40 sine 45. So for 40 sine 45, the total distance is from point A to point B. So here you can see A to E, we already know that 2 meter, and E to this point B. Okay, because B and D are in the same line. So E to D is again 2 meters. So A to B is total distance is 2 plus 1 plus 1. So it is 4 meter. And also it is moving downward. Okay, so take it down and then rotate about the point. Take it down and then rotate about the point. So it will be, it is in clockwise direction. It is rotating in clockwise direction. So 40 sine 45 into 4 plus 40 sine 45 into 4. Is there any forces remaining? No. You can see first diagram, this diagram. There is no force which is remained. So which is equal to 0. This is equal to 0. So take the RE to that side and solve this. Let me know what is the value of RE you got. What is the value of RE? सांगा आन्सर लवकर. RE ची व्हॅल्यू काय आली? 76. अजून एकाने कोणाला तरी आन्सर सांगा मला. सेम आन्सर येते का सांगा.
76.56.
Okay, so RE is equal to 76.56. Unit is Newton or kilonewton? Kilonewton. Kilonewton. As we got positive answer, our assumed direction correct.
Positive.
Okay. So RE is 76.56. So here I will write the value of RE. So this RE is 76.56 kilonewton. Okay. Now after that we will calculate, take summation Fy equal to 0. Now I will take summation Fy equal to 0. So upward forces plus downward forces minus. Then now what we have to count in summation Fy. See here, Va moving upward plus 20 kilonewton moving downward minus Re with respect to AB. Re is moving upward plus, then this 40 sine 45 moving downward minus. So we have to take all these quantities. So here Va minus 20 plus Re minus 40 sine 45 is equal to 0. This is the equation. Now put the value of Re. So if I put the value of Re, then Va minus 20 plus 76.56 minus 40 sine 45 is equal to 0. After solving this, you will get the value of Va.
Minus 28.27.
Minus 28.27 kilonewton. So now here you can see we have assumed the direction of Va in upward direction. आपण Va कसा assume केलं होतं? Upward. इथं आपल्याला आन्सर काय मिळालंय? निगेटिव्ह. याचा अर्थ काय? Va अपवर्ड असायला पाहिजे का डाऊनवर्ड असायला पाहिजे?
Downward.
Downward. Okay. So here I will write therefore हे बघा मी कसं लिहितोय बघा. Therefore Va is equal to व्हॅल्यू Va ची तीच राहणार आहे 28.27 किलोन्यूटन. पण इथं जे समोर मायनस साइन आलेला आहे हे मायनस साइन मला काय सांगतंय तर Va is moving downward. So this is the arrow for the Va. It is moving downward. Then you have to come in this diagram also here. I will erase the Va, direction of Va, and now I will show the corrected direction of Va and it will move downward. This is Va. Okay, this is Va. Now apply summation Fy equal to 0. Sorry, Fx equal to 0. Fy झालं ना already. So apply summation Fx equal to 0. Towards right plus, towards left minus. Now here HA is moving towards right, so it is plus. Then this 40 cos 45, it is also moving towards right, so it is also plus. Only two forces are there. So HA plus 40 cos 45 is equal to 0. Therefore, HA is equal to, what is the answer?
Minus 28.28.
Minus 20.
28.28.
28.28 kilonewton. Now again see, here we have got the minus sign, minus answer. Minus sign indicates that your assumed direction is wrong. Okay. Now HA we have assumed that it is moving towards right hand side. आपण initially असं दाखवलं ना HA before doing the calculation. So HA we have taken moving towards right hand side. But after solving we come to know that the magnitude of HA is correct, 28.28. But this negative sign, it indicates that our assumed direction is wrong. We have to change the direction of HA. So what I will do now, I will change the direction of, just 1 second. Lecture मध्ये सर नंतर बोलतो. Hello. So HA, therefore HA is equal to, I will write here 28.28 kilonewton. But due to this minus sign, I will show its direction opposite. Now it is towards leftward side. Okay. So now here also I need to change the direction. So HA is not in this direction. The correct direction of HA is this one. This is the correct direction of HA. Okay. Now we have solved HA. We know that. Now VA also we have solved. RE value also we have got. Now we will move to this. Second, now consider CG. Okay. Now consider beam CD. You can call this as CD or CG, whatever you want to call, you can call. So here I will write, consider beam CG. Okay. Now if I consider the beam CG, first of all, in this beam, here now, if I take the moment at C equal to 0, if I take moment at C equal to 0, this HC will become 0, VC will become 0. Okay. Then you will get the value of RD. You will get the value of RD. So before that, we have to resolve this force also. Now if I resolve this is my point of application. One line parallel to X, another line parallel to Y. Okay, from the point of application. So these are the result forces. Now this angle is 60 degree. So this will become 20 sine 60. And this will become 20 cos 60. It's 20 cos 60. So 20 cos 60. You can extend this force. This will also pass through point C. So its moment is also 0. If I apply the equation, moment at C equal to 0, clockwise forces are plus, anti-clockwise forces are minus. Then here you can see this HCVC is 0, 20 cos 60 is also 0. Now 20 sine 60, this is the vertical component, 20 sine 60. So what is the distance from point C? So here you can see 0.5 meters, 0.5, because vertical force will be like this. Here it is the vertical force. The distance is 0.5. So 20 sine 60 into 0.5. 20 sine 60 into 0.5. It will rotate in clockwise direction. So plus. Next is the next here you can see this RE. RE is moving downward. Now on this beam, RE will act in the downward direction. 76.56. What is the distance RE? See, RE force is here. C point is here. What is the distance? It is 1 meter. From C to E, distance is 1 meter. So from C to E, this distance it is 1 meter. So this is moving downward. So if you rotate it, it will rotate in clockwise direction. So this is also plus. So 76.56 into 1 plus 76.56 into 1. Again, you can see now RD. RD is moving upward. So C and D, the distance between C point and D point. The distance between C to D is 1 plus 2, 3 meter. So it is minus 3 RD because it is moving upward. So it will rotate in anti-clockwise direction. It will rotate in anti-clockwise direction. So it is minus 3 RD. Minus 3 RD. Next is this moment. By converting this couple, we got this moment. Now this is the anti-clockwise moment of 5 kilonewton meter. Okay, so movement, it must be considered in the equation of summation m only. Okay, you should not consider the moment in the equation of summation fy and summation fx. Okay, because f stands for force and this is not a force, this is a moment. So apply this. So consider this moment in summation m equation. Now this is moving in anti-clockwise direction. So this moment is minus. Okay, so it is, I will write here directly minus 5. Minus 5 because it is in anti-clockwise direction, which is equal to 0. Therefore, RD is equal to, let me know the value of RD.
minus 83.55.
It is minus 83.55. Minus आला का आन्सर?
Yes, sir.
minus 83 point मायनस कसं येतो प्लस यायला पाहिजे की आन्सर.
हा सर प्लस 88.22.
बाकीच्यांनी पण चेक करा बरं का, म्हणजे सगळ्यांनी चेक करा सो दॅट वी विल गेट द करेक्ट आन्सर्स. अदरवाइज इफ वी टेक हिअर रॉंग आन्सर्स अवर प्रॉब्लेम विल बिकम रॉंग. कॅल्क्युलेशन पार्ट मी फक्त तुम्हाला करा म्हणून सांगतो ना, तू बिकॉज यू आर हॅव्हिंग कॅल्क्युलेटर विथ यू, यू कॅन इझिली डू इट. जिथे जिथे मला सहजासहजी लक्षात येते मी सांगतोय पॉझिटिव्ह निगेटिव्ह, बट ऍट द last you are the only persons who are going to calculate this. See, simple thing is there, this quantity is plus, this quantity is also plus, this minus 3rd if I send to that side it will become plus 3rd, and minus 5 I can add or subtract over here. Here you can subtract this minus 5 from these quantities, you will get the answer. So what is the correct answer?
Plus 83.22.
Plus 83.22. Anybody else who has verified this answer? Is it correct?
22 sir, 24 no.
22, sir.
22. Okay. So 83.22. And this RD, we have got the positive answer, so our assumed direction is correct. RD is moving upward. RD is moving upward. Okay. So next. Now what we will do? Now we know the value of this RD. Now we will apply summation Fy equal to 0 so that we will get the value of this Vc, vertical reaction at point C. So now apply summation Fy equal to 0, upward forces plus, downward forces minus. So now here you can see Vc is moving upward plus, then 20 sin 60 is moving downward minus, Re also moving downward, it is also minus. Okay, Rd is moving upward, it is plus. So these forces will come into the picture. What about this 5? 5 ला काय घ्यायचं, प्लस घ्यायचं का मायनस घ्यायचं?
Minus.
मायनस 5. हा काय करायचं बघा, समेशन एफ वायचं मी तर रफ मध्ये लिहितो बघा. मला समेशन एफ वाय इक्वल टू 0 इक्वेशन अप्लाय करायचंय फ्रॉम सी टू जी, सी डी बीम ला अप्लाय करायचंय. मी पहिल्यांदा बघितलं हे व्हीसी वर चाललंय प्लस, 20 साइन 60 डाऊनवर्ड आहे मायनस. वाय एफ वाय म्हणजे फक्त व्हर्टिकल फोर्सेस बघणार मी. आरई डाऊनवर्ड चाललंय मायनस 76.56, आरडी प्लस चाललंय तर प्लस 83.22 अपवर्ड आहे. आता इथं हे जे 5 आहे, व्हॉट आय शुड टेक, प्लस ऑर मायनस? टेल मी ऑन दिस पॉइंट.
सर 5 कन्सिडर करायचं नाही.
Minus.
5 काय करायचं?
कन्सिडर करायचं नाही.
नाही करायचं. का नाही करायचं?
तो फोर्स नाही, तो
Movement आहे.
मोमेंट.
Movement आहे.
Correct. So don't consider this 5. It is not a force. This is not a force. This is moment. Always remember this. And we are applying the summation Fy. तुम्ही हे लक्ष द्या, Fy मध्ये तुम्ही Fy असं लिहिता आणि समेशन Fx मध्ये Fx असं लिहिता. F चं मिनिंग काय? F stands for force. F stands for force. And this 5 kilonewton meter is not a force. So don't consider the moment in this. Okay, this is a moment. So you have to consider this in the equation of summation M. Whenever you apply summation M, M stands for moment, and this is the moment. 5 kilonewton meter is the moment. So consider it in that equation. Okay. So now we will write the equation once again. So this is the rough thing for your understanding I have done here. So now I will write the equation. You also check the equation. So VA, which is moving upward, VA is moving upward, so plus VA minus 20 sin 60 minus RE. What is the value of RE? So the value of RE is 76.56. 76.56 plus RD is equal to 0. Therefore, VA is equal to this 20 sin 60 on that side, it will become plus. This is will also become plus 76.56 and this RD will become minus 83.20. Therefore, VA is equal to, let me know the answer. VA का VC है, point C है ना? Okay. So this is point C. It is not at point A, it is at point C.
10.66.
10.66. Okay. So the answer is 10.66. Positive or negative?
Positive.
Okay. So our assumed direction is correct. It is moving upward. VC. Now, after the calculation of the VC, here we will calculate now HC. So apply summation fx equal to 0. Summation fx equal to 0. Towards right plus, towards left minus. So now when I apply summation fx equal to 0, here you can see this HC, it is moving towards right. It should be considered as plus. This 20 cos 60, it is moving towards left. So it is minus. So here HC minus 20 cos 60 is equal to 0. Therefore, what is the value of HC?
10
10 plus or minus.
plus.
So our assumed direction is correct. So our assumed direction is correct. HC is moving towards this. Okay. So now you can see we have calculated all the values. We have calculated HA, VA, RE, then HC, VC, and RD. Now here at point A and at point C, here it is hinge support. Here it is also hinge support. So we have calculated HA, VA. So now we have to calculate the resultant of this HA and VA, RA, that is remaining, and its angle alpha A, that we need to calculate. Here also the same thing, the resultant of HC and VC, resultant reaction at point C, that is RC, we have to calculate, and the angle is alpha C. So same thing we will do now. So here I will write the resultant reaction at point A. पहिल्यांदा A मधली resultant reaction आपण calculate करूया. So we know that RA is equal to under root HA square plus VA square. So if you put the values, then it is under root. What is the value of HA? HA is 28.28 and VA is 28.27. It is 28.28 square plus 28.27 square. Therefore, RA is equal to, let me know the answer.
28.77.
It is 28.77 kilonewton. Now we need to calculate the direction. So therefore, alpha A is equal to tan inverse in mod VA upon HA. So which is equal to tan inverse of value of VA. VA is 28.27 divided by HA is 28.28. So therefore, alpha A is equal to answer.
$44.71.
44.71 degree. Now at the last, we need to show the diagram. Okay, we have to show the diagram. So what I will do, I will arbitrarily take one point over here. This is my point A. I will say that this is my point A. Okay. Now at point A, HA and VA two reactions are there. So here I will go. I will see first. This is a reaction HA. What is the value of HA? 28.28. And the important is the direction. Where is the direction? It is towards left. HA is moving towards left. So here I will plot this HA, which is moving towards left. This is HA. And I will write here. This is HA is equal to 28.28 kilonewton. This is HA. Now vertical reaction at a VA, you can see. So this is the VA, and it is again VA is 28.27. So the value is same, but it is moving downward. VA is acting downward. So here, what I will do, I will draw the VA, but it is moving downward. So this is VA.
सर
हा
आता
बोला.
मला अल्फा 44.98 आले
हा
चालतं का
हा,
तेवढं
सर.
चालतंय तेवढं. 44 आलाय ना, पॉईंट किती काही न चालतंय, ते कॅल्क्युलेटर वरती डिफरन्स येतोय तेवढा. ओके,
ओके सर
तुम्ही 1 डिजिट 2 डिजिट 3 डिजिट पॉईंट नंतर किती डिजिट कन्सिडर करता त्याच्यावरती ते डिफरन्स येते, तेवढं चालतंय, काय अडचण नाही. ओके, so 44.71 is also correct, 44.98 is also correct. Okay, that much of difference is there. So now this VA, I will write the value of VA. It is 28.27 kilonewton. Now I will complete the parallelogram. So I will drop the vertical line from here, and then this horizontal line from this side, and here somewhere they will meet. Now the diagonal of this will be my RA. So this is the diagonal. This is the RA. So I will write here RA, which is equal to, what is the value of RA? 28.77 kilonewton. Okay. And this angle, it is alpha A, which is 44.71 degree. Okay, this is alpha A. So this is the resultant diagram for RA. This is the resultant diagram for RA. Similarly, we have to calculate it for C. Okay. आता कुणाचं झालं हे? RA चं झालं. Now we have solved it for RA and alpha A. Now same thing we should do for C, because at C also VC and HC both are present. So at point C, now resultant reaction at point C. I will write here resultant reaction at point C. So the resultant reaction at point C we need to calculate. So I will write here RC, that is the resultant reaction, which is equal to under root HC square plus VC square, which is equal to under root HC. What is the value of HC? So here you can see HC 10 kilonewton, and it is moving towards right. So HC is moving towards right, and this VC also here it is there. VC, it is 10.66 and it is moving upward. So HC is moving towards right and VC is moving upward. Okay, that also required. So right now the values we will take 10 kilonewton and 10.66. So here it is 10 square plus 10.66 square. Therefore, what is the value of RC? $14.61. Correct answer.
$14.61.
14.61. Okay. So it is 14.61 kilonewton. This is RC. Now similarly, calculate alpha C. Alpha C is equal to tan inverse in mod VC upon HC, which is equal to tan inverse VC VC is 10.66 divided by HC is 10. Therefore, alpha C is equal to 46.82. Okay. Others, please do check the answer. 46.82 degree. This is the alpha C. Correct. Okay. Okay. So now arbitrarily, now I know RC and alpha C. So now I need to draw the diagram. So arbitrarily I will take this point C. Okay, this is point C. C point. Now here you can see the direction of HC, it is towards right. So that I will plot first. So HC is moving towards right. This is HC. And its value is HC is equal to, it is 10 kilonewton. Next one is VC, vertical reaction at C. It is moving in upward direction. Okay, it is moving in upward direction. So what I will do, I will show it like this. So it is 10.66 kilonewton. This is your VC, vertical reaction. Now again I will join the parallelogram. Okay. I will form the parallelogram, and then here the diagonal of the parallelogram will give me the resultant. So this is RC, which is equal to 14.61 kilonewton. And angle alpha C, this is the angle alpha C, which is 46.82 degree. 46.82. So here now the problem ends. Okay. So anybody is having any doubt, any difficulty, you can ask me. Any doubt, anything you want to ask regarding this numerical, you can ask me.
हॅलो सर.
Huh.
तर माझ्या आरसी ची व्हॅल्यू 13.82 आली.
13.82. ओके, इट इज ऑल्सो करेक्ट. नाव आसपासचा आन्सर चालतंय हो. काय होतं माहिती का, तुम्ही कसं केलं, आता तुम्ही अंडर रूट मध्ये डायरेक्ट टाकून सॉल्व्ह केलं का पहिल्यांदा 10 चा स्क्वेअर केला, मग 10.66 चा स्क्वेअर त्याच्यात ऍड केला, मग स्क्वेअर रूट काढलं, कसं केलं?
डायरेक्ट अंडर रूट मध्ये टाकलं.
हा, मग डायरेक्ट अंडर रूट मध्ये टाकलं तरी आन्सर मध्ये थोडाफार फरक येते, आणि असं स्टेप बाय स्टेप केलं तरी आन्सर मध्ये थोडाफार फरक येतो. ओके, कॅल्क्युलेटर टू कॅल्क्युलेटर तेवढा फरक पडतोय आन्सर्स मध्ये. तर त्याच्या आसपासच आन्सर्स येतात, आणि एक्झामिनर नोज दॅट while checking the paper. Examiner knows that the answer will be near to this and this, so you will get the marks for that. Don't worry about it. Okay. Anything else you want to ask? Don't worry for the calculations. Exactly point to point same कुणाचेच आन्सर येणार नाहीयेत. तुमच्या प्रोसिजर वरती डिपेंड आहे. सी, देर आर टू प्रोसिजर्स टू कॅल्क्युलेट दिस आन्सर ऑन द कॅल्क्युलेटर. मला जर याचा आन्सर काढायचा, इफ आय वॉन्ट टू calculate the answer of this step in the calculator, what I will do nowadays in the modern calculator, you can directly apply the square root sign, and under the square root sign in bracket you can write these quantities, and directly if you press equal to, you will get the answer. So that answer is like that 13 point something you will get. But normally if you do the calculation in this way, that first of all, instead of placing this square root sign, you do 10 square. Okay, you do this calculation first. In 10 square plus 10.66 square, you will get some answer. It's 3-4 digit answer over here. And then you take the square root of that answer. Then you will get this one, 14.61. So there will be the, due to this procedure, you have taken the different approach to solve this step. So depending upon that, you will get somewhat difference in the calculation. Okay, so calculator itself takes the further digits into the calculation, and due to which it will create some difference in the answer. But that difference should be very, very small. 1 kilonewton, 2 kilonewton, ठीक है. It should not be the case that answer is 14.61 and you are saying that answer is 4 kilonewton. it should not be the case. Okay, 14.61, then 12 or 13, 15, those are considerable answers. Okay, so instead anything else, anybody who want to ask anything about this numerical what we have solved right now? Have you understood this part, how this 5 kilonewton meter come? I'm asking to all of you, have you understood this part?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. This RE, it is taken upward here, it is taken downward here. This part also have you understood? I think
Yes.
yesterday this type of problem we have taken now, where one reaction it is upward to the one beam and downward to the another beam. So if everything you understood, then we will take the next numerical. It is of a frame. We will solve one frame now. So shall we move to the next problem or anything you want to ask? सांगा स्पीकअप, वेळ घालवायचा नाही. समजलं असलं पुढचा प्रॉब्लेम घ्या म्हणून सांगायचं. अदरवाईज इफ नाही समजलं तर विचारा मला काय अडचण आहे ते. Okay, so shall we take the next problem then?
Yes, sir.
Okay. Now we will solve one small frame. We determine the support reactions at A and C of the structural frame shown below. Now I'm drawing the diagram. This is inclined roller, which is inclined at an angle of 30 degree. So angle is 30 degree. Now here at this point somewhere, there is a clockwise moment acting in this way. This moment is 50 kilonewton meter. Okay. This clockwise moment is 50 kilonewton meter. So here triangular load is acting, UVL. It is acting like this, UVL is there. Not trapezoidal load given. Trapezoidal load is not given. They have directly given us triangular load. So it is acting like this. The simple load is given. Instead of trapezoidal, triangular load is given. So this is the loading. Now the dimensions are this is 4 meter. Height is 4 meter from the support. this ordinate, this ordinate, it is 40 kilonewton per meter. 40 kilonewton per meter. Then from this point up to here, I will show this point, this distance. Okay, if I project this, here distance and a distance. Okay, this distance and this distance also. So these two distances, those are given. So these are 1.5 meter each. I will give the name A, B, this is my point C, this is D. At point A, C म्हटलेलं आहे का? So here I will change the name A and D. A and D. This is the given diagram. Now you think on this. See, we have solved so many number of problems. Now you think on this and you tell me how to solve it. पहिल्यांदा काय काय करायला पाहिजे इथनं सुरुवात करा. फर्स्ट स्टेप काय, अशी डायग्राम बघितल्यावर आपण काय करतो पहिल्यांदा? नॉर्मल बीमचा प्रॉब्लेम आहे. नॉर्मल प्रॉब्लेम इज गिवन टू यू and it is asked to find out the reactions. What is our first step? What we do first?
लाईन डायग्राम ड्रॉ करायची.
Line diagram. Okay, that is free body diagram. First we will draw free body diagram along with line diagram. So here I will draw the diagram. Okay. So at this point A, it is hinge support is given. So there are two reactions. This is VA and HA. Okay, these are the reactions at point A. Then at this point, see here at this point D, the reaction will be like this. There is only one reaction, but that reaction will be perpendicular to the surface on which the roller rests. So this must be 90 degree. Okay. So this angle, if I drop the perpendicular from this point, so if this angle is 30 degree, this angle with vertical is also 30 degree. We have seen in the previous numericals. So here I will draw it like this. This is the reaction RD, and this angle it is 30 degree. This angle is 30 degree, and here is the moment 50 kilonewton meter, and here is the triangular load. So this ordinate is 40 kilonewton per meter. Now this diagram is complete. Okay, so here you can resolve maximum. Here what you can do, you can resolve this. I will resolve this RD. So one component is moving upward, another component is moving towards left. So this will become RD cos 30, and this is RD sin 30. Now the diagram is complete. So this is my point C. What is the next step? We have drawn the line diagram. सांगा नेक्स्ट स्टेप काय करायचं?
Convert triangular load into point load.
कन्वर्ट करायचं, मध्येच कन्वर्ट करायचं आताच. मुवमेंट घेताना कन्वर्ट करावं लागणार ना.
Yes, sir.
Yes, sir.
आता काय गरज आहे उगीच कन्वर्ट करून कुठे ठेवायचं त्याला? ओके, सो वेन यू आर टेकिंग द मोमेंट ऍट दॅट टाइम, आणि मी तुम्हाला सांगितलंय तसलं कन्वर्ट करून एरो बिरो दाखवायचे नाहीत. हे जे कन्व्हर्जनचं काम आहे तुमच्या डोक्यात मनात चाललं पाहिजे. ओके, तुम्हाला ट्रायंगल बघून लक्षात यायला पाहिजे. सी, वन्स यू सी दिस ट्रायंगल नाव, it should come into your mind that this is 40, this base, this distance, it is given as 4 meter, this is 4 meter. म्हणजे मला हा बेस 4 आहे माहिती, हे 40 माहिती आहे. डोक्यात तुमच्या लगेच यायला पाहिजे हाफ इंटू बेस इंटू हाईट, हाफ इंटू 40 इंटू 4 मला करायचंय. हाफ इंटू 40 इंटू 4 म्हणजे माझं काय तर पॉइंट लोड आहे, ही मुवमेंट नाहीये. हे डोक्यात ठेवायचं परफेक्ट. ओके, सो नाव see here, we want to calculate the reaction HA, VA and RD. These we need to calculate. So what we will do now? We will do one thing. We can take the moment of all the forces at point A equal to 0, so that this HA and VA will become 0 and we will get the value of this RD. So how to do it? Let us take the moment. So now I will take here summation M about A is equal to 0. Clockwise moments again positive, anti-clockwise moments negative. So I am taking the moment at this point is first is this triangular load. So while taking after writing the equation of the moment, now I want to take the moment of this triangular load about this point A. So moment of this triangular load. So first of all, I need to convert the triangular load into the point load. So how do I convert this triangular load into the point load? I should take the area of this triangle. Okay, so I should take the area of the triangle. So area of the triangle is half into base into height. Okay, half into base into height. Because this is 4 meter, they have already given to us 4 meter height. Okay, so half into base into height, it is the conversion of UVL into the point load. म्हणजे हे जर मी कॅल्क्युलेशन केलं तर मला काय मिळेल? पॉइंट लोड मिळेल. Okay, this is not a moment. Now multiplied by lever arm. Okay, multiplied by lever arm. Lever arm किती येणार सांगा आता? Perpendicular distance of this point load from A किती येणार? What is the perpendicular distance of this load from point A when you convert it into the point load? What is the distance? सांगा मला कॅल्क्युलेट करू किती येते? Let me know the answer. किती आलं?
2.66.
2.66. Correct. It is right answer. सगळ्यांना कळलं का 2.66 आन्सरच आहे? Answer 2.66 means perpendicular distance is 2.66. Everybody, or shall I tell it in this diagram? समजलं? हा, बघा इकडे. फक्त तुम्हाला काय नाही, नेहमी ट्रायंगल जो आडवा दिलेला आहे त्याला उभं केलेलं आहे. असा ट्रायंगल असताना तुम्ही सेंट्रॉइड काढता ना. सपोज नाव दिस टाइप ऑफ राईट अँगल ट्रायंगल इज गिवन. हे जर असं दिलं असतं, समजा हे ऑर्डिनेट आहे 40 किलो न्यूटन पर मीटर आणि हे डिस्टन्स आहे 4 मीटर. नाव आय वॉन्ट टू कन्वर्ट दिस UVL into the point load. Okay, this type of UVL is there, suppose. Arrows वगैरे दाखवले. This type of loading. Now what I will do to convert that into the point load? It is half into 4 into 40. So this half into 4 into 40 is my point load. This is point load. Okay. Now still I have to multiply it by the distance. So here see, suppose now point A is here, and I want to take the moment at point A. What I will do? I will calculate, see where is the CG of this rectangle. So where is the CG? What is the formula? From right angle, this CG at a distance of B by 3. From right angle, the CG at a distance of B by 3. So if this is B by 3, B means base. What is the base? Base is 4 meter. Okay, B means base. Base is 4 meter. So this B by 3 is equal to how much? It is 4 by 3, which is equal to 3 ones are 3, 3 threes are 9, 1.33. ओके 1.33. पण मला हे डिस्टन्स नकोय, मी मुवमेंट कुठल्या पॉइंटला घेतोय? ए पॉइंटला. ए पॉइंट कुठे आहे माझा? इथे आहे. तर आपण काय करणार मग त्या केसमध्ये? वी विल कन्सिडर द डिस्टन्स फ्रॉम दिस पॉइंट टू टेक द मोमेंट, अँड दिस डिस्टन्स विल बी 2.66. सो आय शुड मल्टिप्लाय इट बाय 2.66. असं ही डायग्राम, हीच डायग्राम फक्त इथं उभं केलेली. काय फरक आहे? सो नाउ वी विल सी इन दिस डायग्राम ऑल्सो. सेम कॉन्सेप्ट विल बी देअर. शेप सेम आहे म्हणजे सीजी चा फॉर्म्युला सेमच राहणार. So now here I will show this angle is 90 degree. This angle is 90 degree. So somewhere here the CG will be there. Somewhere here at this point. So somewhere here the CG will be there of the load. And from here this load is acting. If you convert this into the point load, it will act like this through this CG. It will act through the CG. That is the centroid. And now, if I calculate the distance, this distance from right angle, how much? What is the formula? What formula says? It is B by 3, which is equal to 4 by 3. Okay. And now what is the, but we don't want that distance. Hey, distance पाहिजे का आपल्याला नाही, because we are taking moment at point A. So from point A we need the distance. So our required distance is from this point A up to here. This is our required distance. This is our required distance. And what will be that distance? If this total is 4, total दिलेला आहे तुम्हाला, from A point to this point, this C, A to B, what is the distance? 4 meter. So this total is 4. So from that 4, if you minus this 4 by 3, that is 1.33. This remaining distance you will get, and this remaining distance, this is 2.66. The remaining distance is 2.66. So I will multiply this by 2.66. Now it is a moment. Now it is a moment. Also see, this force is moving towards right. So it will rotate in clockwise direction. So this is plus. This quantity is plus. Okay. समजलं का? यस नो, कुणाला समजलं नव्हतं सांगा म्हणतो. ते कळालं का? कसं आलं का? नाही कळालं अजून?
कळालं सर.
Okay. So now after this triangular load, we will move to this moment. 50 kilonewton meter. या मुवमेंटला कन्सिडर करायचं का नाही करायचं? आता समेशन एम च्या इक्वेशन मध्ये ए, समेशन एम ए
करायचं.
करायचं. Okay, good. So this moment it is rotating in clockwise direction. The direction of the moment is clockwise. Plus घ्यायचं का minus?
प्लस.
This is plus 50. Plus 50. Then now see here. First this RD cos 30. RD cos 30. Point A is here. So what is the perpendicular distance of this RD cos 30 from point A?
3 मीटर.
3 meter. Correct. समजतंय सगळ्यांना 3 मीटर कसं आलं? दिलेलं आहे ना इथं 1.5 1.5. सो हे टोटल 3 असायला पाहिजे एवढं. हेच आहे ना perpendicular distance. If I extend the line of action of this force, see, this is the line of action. And now if I want to calculate the perpendicular distance of RD cos 30, so you can see This is the from a point A, this is the perpendicular distance. And this distance, it is 3 meter. Why it is 3 meter? Because this is 1.5, this is also 1.5. From this point to this point, 1.5. From here to here, it is also 1.5. So this total is 3 meter. This is the distance. So it will be RD cos 30 into 3 about this point. It is RD cos 30 into 3. RD cos 30 into 3. Okay, RD cos 30 into 3. So RD is moving upward, so it will rotate in negative anti-clockwise direction, minus. Now this after this RD cos 30, you think about this RD sin 30. Now where is the RD sin 30 here? This is the line of action of RD sin 30, this topmost line. We are taking moment at point A. What is the distance of this RD sin 30?
4 meter.
4 meter. Okay, this distance will be 4 meter. Again, this RD sin 30, if you rotate it about point A, it will rotate in anti-clockwise direction. Okay, it will rotate in anti-clockwise direction. So here, RD sin 30 into 4, this is also minus, which is equal to 0. Therefore, RD is equal to. Solve करा and वाला answer सांग. What is the answer? You are taking too much time.
57.25 kilonewton.
Positive or negative?
Positive.
Positive.
Okay, so our RD's direction is correct. Whatever the direction we have shown for the RD, that direction is correct. So this is the direction of RD. This is the direction. This direction is correct. So after the calculation of this RD, now apply summation Fy equal to 0. So VA is moving upward plus. Okay. So now VA is moving upward, so it is plus. Now HA will not consider horizontal. Now what about this triangular load? प्लस घ्यायचं का मायनस घ्यायचं याला? Summation Fy equal to 0. VA next is this triangular load. कसं करायचं? प्लस घ्यायचं का मायनस घ्यायचं?
It is act as horizontal. It is not considered.
This will not consider because it is horizontal load. It should be considered in summation Fx. Summation Fy मध्ये येणार नाही. आडू बघा आडवेत ना बाण सगळे. So this is the horizontal load. Next in this moment काय घ्यायचं ते प्लस का मायनस कसं घ्यायचं?
It is not considered.
It is not considered. Okay, because it is a moment. Next is this RD cos 30. It is also moving up. So I will write plus RD cos 30. RD cos 30. Then any other force is there? No. So which is equal to 0. Therefore, VA plus 57.25 RD. What is the value? VA
Minus 49.49.
minus 49.49 kilometer. Now this minus sign is there. Therefore, VA is equal to, it is 49.49 kilonewton, but VA should be downward. It should not be up. Okay. This is what is the meaning of the negative sign. Now, after this, VA झालं. Now apply summation fx equal to 0. Apply summation fx equal to 0. Towards right plus, towards left minus. Here you can see if I apply summation fx 0, then HA it is moving towards right plus. Then this triangular load, it is half into 4 into 40. It is also moving towards right. This is also plus. This moment we will not consider. Then this is minus RD sin 30. So here I will write HA minus triangular load half into base into height. Okay. Minus RD sin 30 is equal to 0. Put the value of RD over here. So you will get the value of HA. Therefore, HA is equal to half into base into height plus RD sin 30. These two minus terms will become plus. RD, what is the value of RD? 57.25 sin 30 now in the equation. Therefore, HA is equal to
minus 51.37.
minus का स्केलर Okay, so this term is plus. So this will become minus. And this is plus. So किती आला answer? Minus. What is the answer? Can you repeat the answer? किती आला?
51.37.
61.37.
51.
51. Okay. 51.37. So therefore now HA is equal to, I will write here 51.37 as it is, and this is sign is minus sign, so I will change the direction of HA. HA instead of moving towards right, HA will be moved towards left. This is the direction of HA. So we will change the direction of HA and VA in this diagram also. So HA and VA. So here, this is the direction of HA, corrected direction. This is the corrected direction of VA. This is the corrected direction. Now we have to find out resultant of HA and VA. Okay. We have to find out the resultant of this HA and VA. So therefore, RA is equal to square root HA square plus VA square. Therefore, RA is equal to in square root HA square 57.37 square plus VA square 49.49 square. Therefore, RA is equal to, what is the answer? Let me know the answer.
56.65.
56 point
65.
positive. Okay, because it is plus. Correct. 56.65 kilonewton. This is the value of RA. Now calculate alpha A. Alpha A is equal to tan inverse in mod. Tan inverse in mod. It is VA upon HA. VA upon H. Okay. So therefore, alpha A is equal to tan inverse of value of VA 49.49, HA 51.37. 49.49 divided by 51.37. Therefore, alpha A is equal to, what is the answer?
43.93.
43.93 degree. So now finally, I have to draw the diagram. Okay. So here, what I will do, I will take one point. This is my arbitrary point. Let us call this point as point A. Now from point A, you can see here reaction VA is there. What is the value? 49.49. It is moving down. Okay. So VA is moving downward. So I will draw VA, which is moving downward. This is VA. 49.49 kilonewton downward. Then HA. This is horizontal reaction which is moving towards left. 51.37 moving towards left. So this is 51.37 HA 51.37 kilonewton moving towards left. Now complete the parallelogram. And now draw the diagonal. This is the diagonal. So this is your RA. So this angle, it is 43.93 degree. And this is RA, which is equal to, what was the value of RA? 56.65. 56.65 kilonewton, which is RA. This is the final diagram for this frame. Okay. This is the final answer. Once again, see the diagram. Let me know if any problem is there. Is there any problem?
No, sir.
Okay. Next numerical. Find out the reactions. Find out the reactions of a cantilever beam shown below. So I will draw the diagram now. This is the given beam. This type of support is given. Here there is a point load which is of 30 kilonewton. Then there is a, what you can say, uniformly varying load from this point only, from here. And this ordinate is 20 kilonewton per meter. This is 20 kilonewton per meter. Then here, after at some point, there is a moment. There is a moment like this. This is the moment. 20 kilonewton meter. 20 kilonewton meter. This is the moment. And lastly, again, UDL is given. This is also 10 kilonewton per meter. Ten kilonewton per meter. Now I will write the distances. So from this point to this, it is 3 meter. From here to here, it is 6 meter. This is 3 meter, this is 6 meter. Again, then this is 1 meter. Then again 1 meter. Gap between these two, this is 1 meter. And lastly, the UDL, which is situated over here, this is at distance of 3 meter. This distance is 3 meter. Okay, now you have to find out the support reactions. Let us say that this is the point A. कुठल्या टाईपचा सपोर्ट आहे आधी ते सांगा. So here the support is provided at only one end. This is called as cantilever beam. Okay. Normally तुम्ही घराची गॅलरी जर बघितली, गॅलरी, in the galleries these types of beams are provided. एका बाजूला तर तुमची भिंत आहे, दुसऱ्या बाजूला तुमची गॅलरी ही काय असते, कॅन्टिलिव्हर. There is no support to that gallery from the bottom. Okay, you can check anywhere. So at that time, these types of beams are used. Now you tell me which type of support is there at point A. Now काय त्या सपोर्टचं? बघा वहीमध्ये काढून लिहून दिले की तुम्हाला टाइप्स ऑफ सपोर्ट्स. Which type of support? This support which is shown at point A, what is the type of support? Tell me the name, which type of support it is.
Fixed support.
Fixed support.
Fixed support, okay. So this is called as fixed support. So how many reactions are there for fixed support?
3 reactions.
3 reactions, okay. So 3 reactions. One is vertical, another is horizontal, and third is the moment. Okay, this is vertical reaction, this is horizontal reaction, and this is moment. So all the three reactions are present at the fixed support. So here I will show the reactions first. Okay, so see, this is the vertical reaction at point A. I will show here itself in this diagram only. Then this is the horizontal reaction at point A. And finally, this is the moment at point A. This is the moment at point A. So now if I give the name, this is VA, vertical reaction at point A. This is HA, and this is called as MA, moment at point A. So we don't know whether the moment is clockwise or anti-clockwise. बघा, इथं मी moment अशी दाखवली, असा काही रूल नाही की असं दाखवायला पाहिजे. So I have initially shown this in this direction anti-clockwise. जसं आपण V upward दाखवतो, HA horizontal दाखवतो, right ला दाखवतो, आणि त्यांचा आन्सर जर निगेटिव्ह आला तर आपण ही डायरेक्शन चेंज करतो. Same way, I have shown this moment MA in the anti-clockwise direction. If we get negative answer, we will change the direction of MA. Same thing is applied. Okay. So now to find out the reactions, what we will do now? We will take moment of all the forces about A equal to 0. So all the clockwise moments are positive, anti-clockwise moments are negative. So now at A, if I taking the moment, so VA is 0. Okay, because VA is passing through point A, so its perpendicular distance is 0. That is why VA is 0. Okay, HA is also passing through point A, so the perpendicular distance of HA is 0. So therefore the moment of HA is 0. So what is remain at point A? MA will remain as it is. It is externally applied moment MA. बरोबर ना? MA ला कुठं perpendicular distance आहे का MA ला? असते का? नाही, कारण ही मुवमेंट आहे. हे HA आणि VA काय आहेत? रिएक्शन आहेत. रिएक्शन म्हणजेच फोर्स. समजतंय? मग त्याला परपेंडिक्युलर डिस्टन्स असणार आहे, कारण HA आणि फोर्सला आपण परपेंडिक्युलर डिस्टन्सने मल्टिप्लाय केल्यावरच मुवमेंट मिळते, आणि आपण मुवमेंटचं इक्वेशन घेतोय. त्यामुळे यांच्या दोघांचे परपेंडिक्युलर डिस्टन्स हे 0 होते, HA आणि VA चे, म्हणून यांच्या मुवमेंट 0 झाल्या. पण MA ही ऑलरेडी मुवमेंट आहे. MA इज नॉट अ फोर्स. त्यामुळे MA ऍज इट इज इथे येणार, कारण MA ला परपेंडिक्युलर डिस्टन्सच नाहीये. MA ला जर परपेंडिक्युलर डिस्टन्स नाहीये तर तो 0 व्हायचा काही संबंध पण नाही. ओके, so therefore this MA I have taken in anti-clockwise direction, so I will write here MA like this. Okay, then the moment of this 30 Newton force, this 30 Newton force, it is at a distance of 3 meters from this end, and it is moving downward, so it will rotate in clockwise direction. So this is plus. So here it is, I will write plus 30 into 3. Plus 30 into 3. The next one is this uniformly varying load. Okay, so convert this load into the point load first, then take the moment. So now it is moving downward, so it will also rotate in clockwise direction. So plus conversion of UL into the point load, half into base into height. Area you should consider. Half into 6 into 20. Half into base is 6, height is 20. Into now perpendicular distance. So this point load will act through the CG of this diagram. Okay, if I show you the CG, then the CG of this triangle may be somewhere here. It is at a distance of B by 3 from right angle. B by 3 from right angle. Okay, so what is the distance now? B by 3 from right angle. Then किती येणार मग डिस्टन्स? हे जर टोटल 6 असेल तर B by 3 म्हणजे हे किती झालं? किती येईल? एवढं डिस्टन्स किती येईल?
2.
It is 2 meter. B by 3 means 2 meter. Now if this total is 6, see, from this point up to here it is 6. मग राहिलेलं एवढं किती असणार आहे? या पॉइंट पासून या पॉइंट पर्यंत किती असेल?
4.
It is 4 meter. मग हे डिस्टन्स पाहिजे का आपल्याला 4? आपण मुवमेंट कुठल्या पॉइंटला घेतोय?
A point ला total
Ah.
distance 7.
7. Okay. So we are taking the moment at point A. So the distance, this point load will act through the CG. हा point load जो आहे तो असा act होणार आहे. Okay, this point load will act here, right, like this. Okay. So now here is the load. That is half into 6 into 20. This is the load. Point is here, A. So what is the total distance? This is the total distance. Okay. So it will be, this is 4 and plus 3. So total will be 7. So you need to multiply this by 7. Total distance is 7. Okay. Then this moment, it is rotating in clockwise direction. So it is plus 20. Am I right? Plus 20.
Yes, sir.
Okay. And lastly, this UDL you have to consider. This UDL is also acting downward. So if you rotate this, it will rotate in clockwise direction. So I will take right here plus. Now convert this UDL into the point load first. So conversion of UDL into the point load is 10 into 3 into. Okay, so when you do 10 into 3, this load will act at the center. This is the point load, 10 into 3 point load. And it will act at the center of this 3 meter. It will act at the center of this 3 meter. So if it is acting at the center, then this much of distance from this point up to here, this is 1.5. Okay, this is 1.5. As this total is 3. So what is the lever arm now for the multiplication? It is from point A, I should take the distance of this force because I am taking the moment at point A. So from point A, what is the distance of this force? It will be 3 plus 6, 9 plus 1, 10 plus 1, 11 plus 1.5. So it is
12.5.
12.5. 12.5. Which is equal to 0. Now solve this so that you will get the value of this MA. Moment at A.
905.
What is the answer?
905.
905. Okay. So the answer is 905 kilonewton meter. Positive answer मिळालं का negative answer मिळालं?
Positive.
So the answer is positive. So this our assumed direction is correct. So MA is in anti-clockwise direction because we have taken here it is anti-clockwise and we have got the positive answer. So our assumption is correct. जर आपण अँटी क्लॉकवाईज इथं डायरेक्शन दाखवली आणि इथं आपल्याला निगेटिव्ह आन्सर जर मिळालं असतं तर आपण ही डायरेक्शन चेंज करून क्लॉकवाईज दाखवली असती. कळलं? सो निगेटिव्ह साइन इंडिकेट्स अस द डायरेक्शन वेदर वी आर करेक्ट और नॉट. So now we have got this value MA. Now apply summation Fy equal to 0 so that we will get the value of this VA. Okay. So apply summation Fy equal to 0. So right here summation Fy is equal to 0. Upward forces are plus, downward forces are minus. So now if you use the equation of summation Fy, here C plus VA is moving upward, so plus VA. Then this 30 kilonewton force, it is moving downward, so it is minus 30. Then this UVL, it is also moving downward, so this is also minus, but you have to convert this UVL into the point load. So it will be half into 6 into 20. Now this is my point load. Next is this 20 kilonewton meter. किती घेऊ? Plus 20 का minus 20? किती येणार? Plus 20 घ्यायचं का minus 20 घ्यायचं?
सर ते घ्यायचं नाही.
घ्यायचं. Correct. So 20 will not come in this equation as we are using the equation of summation Fy. F stands for force, not for the moment. So leave this 20. Now this UDL. So convert this UDL into the point load and it is acting downward. So it is minus 10 into 3, which is equal to 0. So therefore, let me know the answer. VA is equal to
120.
positive answer आलं का negative?
Positive.
Positive. Assumed direction is correct. It is upward. Okay. Now apply summation Fx equal to 0. Summation Fx equal to 0. Towards right plus, towards left minus. Now see here. This is HA. HA is moving towards right. So plus. Then is there any horizontal force acting on the beam? आहे का HA घेतलं towards right plus. अजून कुठला फोर्स येईल का याच्यातला Fx मध्ये?
नाही.
Nahi. Okay. So here HA must be 0. So HA is equal to 0 kilo. So जर HA 0 झाला, ओके, तर RA आणि VA तुमचं काय असणार आहे? सेम असणार आहे. देर इज नो नीड टू कॅल्क्युलेट द RA सेपरेटली. समजतंय ना? हे HA आणि VA ह्यांचा रिझल्टंट RA. Okay, the resultant is RA. But if the HA is 0, then your RA and VA must be equal. It will lie on the same line. So you can directly write RA is equal to VA is equal to 120 kilonewton. So here RA is equal to VA is equal to 120 kilonewton. Your HA is 0. So in this way you need to solve this. Okay. समजलं का?
Yes, sir.
तुम्हाला कधी कधी वाटतं तुम्हाला सगळंच समजलं म्हणताय, तुम्हाला डाऊट कसं काही येत नाही कशावरती, विचारत नाही काय नाही, मग एक तर तुमचा अभ्यास चांगला चाललाय, नाहीतर तुम्ही काहीच करत नाही, असे दोनच अर्थ होते. ठीक आहे, समजते ही चांगली गोष्ट आहे. ओके. I'm taking some new variety of the problem now.
पुढचं ओपन करा पेज.
पुढचं. ओके. Any doubt in this? Okay, now I will write the problem over here and you have to solve that problem. You have to attempt. तोपर्यंत मी अटेंडन्स पण घेणार आहे आणि त्याच वेळी तुम्हाला प्रॉब्लेम सोडवत द्या अटेंडन्स. Now this problem is for तुम्हाला सोडवायला देणार. You have to solve this numerical right now in front of me here only. You should give me the answers. So find the support reactions of the beam as shown below. And the diagram is given. This is the beam. Here is point A. Then the inclined load, it is acting over here. This is of 10 kilonewton. 10 kilonewton. This angle is 45 degree. 45 degree angle. And here is the UDL. This is of 15 kilonewton per meter. Then at this point, this type of loading is there. here this intensity is 10 kilonewton per meter, and this total intensity is 20 kilonewton per meter. This total intensity. And the support at the next end, it is given over here, and it is inclined roller support. So here is the roller support. This angle is 30 degrees. Okay, now I will give you the distances. So all the distances are 3 meter, 3 meter, 1.5 meter, 4.5 meter. Okay, and this point, it is called as point B. This is C, D, E. So find the reactions. Now solve the problem. Start to solve. And simultaneously now I will take the attendance. Rule number 1,
Present.
2, 3, roll number 4,
Present, sir.
5,
Present, sir.
6,
Present, sir.
7,
Present, sir.
8,
Present, sir.
9,
Present.
10,
Present, sir.
11,
Present, sir.
12, 13,
Present, sir.
14, roll number 14, 1, 4, 15, roll number 15, 16,
Present.
17,
Present, sir.
18, roll number 18, 19,
Present.
20,
Present, sir.
21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33, 33, 34,
Present, sir.
35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38, 39,
Present, sir.
40,
Present.
41, 42, 43,
Present, sir.
44, 45,
Present, sir.
46,
Present, sir.
47, 48,
Present.
49, 50,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, present, okay. 54,
Present, sir.
55,
Present, sir.
56, roll number 56, 57, 57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60, 60, 60, 61,
Present, sir.
okay. So now I will read once again the absent roll numbers. Okay, you can check once again. Roll number 14, 1-4, absent. Roll number 18, 1-8, 41, 42, 47, 56, and 60, 60. These are the absent roll numbers for today's lecture. Anybody from these numbers is present, then you can tell me. Okay. So have you solved the numerical? Problem सोडवला का दिलेला? What is the answer? कसं कसं सोडवणार, काय काय केलं? Have you resolved this RB? Have you shown the reactions here at this point A? There are two reactions, that is, this reaction is VA, vertical reaction, and then horizontal reaction HA at this point A. At here RB, there is only one reaction, it is like this. This is the RB. This you can call this as HA, VA, and RB. मग HA, VA आणि RB तर कॅल्क्युलेट करायचं होतं ना तुम्हाला, म्हणजे RA आणि RB. रिप्लाय द्या कुणीतरी, कुठपर्यंत आलंय सोडवत सोडवत, कुठल्या स्टेपला आहे सध्याला तुम्ही आता? एनीबडी फ्रॉम यू? Have you applied the equation summation m about a equal to 0?
Yes, sir.
Okay. So when you apply moment at a equal to 0, you should get the value of RB. मिळाली का RB ची व्हॅल्यू?
Yes, sir.
What is
24.9.
80?
24.99.
24.99. Here 83 or something answer is there. 83.24 here the answer is given for RB. What is your answer? So this,
Let me check once again. I will check the calculation.
you check the calculation, and this is your homework problem for all of you. Okay. To help you, just I will tell you two things here. If you drop the perpendicular from this point like this, then UVL and UDL, both the loads will be there. Okay. So now when I think about this load, only this UDL. Okay, this is the UDL. Okay. This is the UDL. So here, when I apply the equation summation m about a equal to 0, clockwise plus anti-clockwise minus, this is just I am giving hint. त्यामुळे मी शॉर्ट मध्ये लिहितो, तुम्ही व्यवस्थित सॉल्व करायचं आहे. V and HA will become 0. If you resolve this, then you will get one component 10 sine 45 and its distance will be 3 and this term is plus. Okay, then again plus this UDL, conversion of UDL into the point load 15 into 3, then it will act at the center. So this is 1.5, this is 3, so this will be 4.5. Okay, then again plus this UDL, conversion of UDL into the point load 10 into 4.5 into, so it will act at the center of this 4.5. So it is 3 plus 3 6, 6 plus 1.5 7.5, 7.5 and plus 2.25, so it will be 9.75. 9.75. Then this triangular load you should consider plus half into base is 4.5 into height. Now this above height you should consider, this is the height of the triangle. So if this is 10, this is 20, this remaining is also 10. So height will be 10. Okay, height is 10 multiplied by its CG now. Now you can see over here, this angle is 90 degree. This angle is 90 degree. So its centered will be somewhere here. B by 3 from this end. So B by 3 means 4.5 by 3. Okay. So B by 3 means 4.5 by 3. So how much it is?
1.5.
1.5. Okay, 1.5 plus, and now we have to take the moment from point A. So it will be 3 plus 3, 6 plus 1.5. It is 7.5, 7.5 plus again 1.5. Here is the CG. Okay, so it will be 9. It is 9. And then after this, here you have to resolve this RB, and the cost component of RB will be there for the total distance. Total distance is 4.5 plus 1.5. It is 6 plus 9 plus 12. Okay, so it is minus 12 RB cos 30 is equal to 0. So this is your equation. If you got this equation, then your answer will be correct. Okay. असं आलं तर इक्वेशन, जर येत नसेल तर सगळं माहित असून आपलं कुठं चुकतंय, काय प्रॉब्लेम येते, काय नाही, ट्राय टू आयडेंटिफाय दोज पॉइंट्स and you can ask me on those points. Okay, now see how fastly I have written the equation. I was doing the calculation in my mind and I am writing. So in this way you should do all the calculations. Okay, so now practice this problem. This is the equation I have already written on the board. Once again draw this diagram and try to solve by your own. Many numericals we have taken, so try to solve those numericals by your own, and when you are getting stuck at that point you should see the answer, so that you will understand that where you are getting the problem while solving these numericals. Okay, so now today we will stop over here. In the next lecture, before coming to next lecture, you do one thing. How many students are there right now here? 53 students are there. Okay, so I will tell you one app. There is one app which name is Kahoot, K-A-H-O-O-T. Okay, K-A-H-O-O-T. If you search in the Play Store or if you search in the Google, you will get this Kahoot app. Download it and install it in your mobile. Okay, When it asks you to open the account with college mail ID. This Kahoot. So by using this app, we will take some test, quiz, test, quiz. Quiz we will take, not test. Quiz we will take by using this app. Okay. So search and download this app. Huh?
MCQ type का?
MCQ type. Okay. So search this.
Still don't have college mail IDs.
You don't have, then open it with your personal mail ID. No problem. Okay. If you are not having college mail IDs now, then open the account with your personal mail ID. जसं तुम्ही Gmail वर open करताय same way तिथं. काय अवघड नाही. Open करून ठेवा. So in the next lecture we will see how we can use it and how we can take the MCQs. Okay. Okay. And also on the YouTube you can see the video of this app. How to use the Kahoot app as a student. You can search on the YouTube that how to use Kahoot app as a student. असं तुम्ही टाका YouTube वरती. You will also get lot of videos. You will come to know that what this app is all about. Okay. So we will see it in the next lecture. So next lecture किंवा त्याच्या नंतरच्या लेक्चरला आपण ह्याच्यावरती घेऊ. पण तुम्ही डाउनलोड करून ठेवा नेक्स्ट लेक्चरला. Okay. So we will stop over here. How many syllabus for unit test 2? Okay. UT1 ला आपण काय घेतला होता सिलेबस? कुठपर्यंत घेतला होता?
फर्स्ट चॅप्टर.
मग आता आपलं उद्यापासून किंवा परवापासून थर्ड चॅप्टर चालू होईल. आता हे संपलं ऑलमोस्ट. भरपूर प्रॉब्लेम घेतलेले आहेत आपण. तुम्हाला उद्याच्या लेक्चरमध्ये मी एक व्हर्च्युअल वर्कचा फक्त कॉन्सेप्ट सांगतो, फक्त 5 मिनिटाचाच आहे. त्याच्यावर तुम्हाला न्यूमरिकल्स नाही आहेत. अँड देन वी विल मूव्ह टू द नेक्स्ट युनिट. सो सेकंड चॅप्टर पूर्ण असणार आहे युटीला आणि थर्ड चॅप्टर वरचं जेवढं काय होईल तेवढं सगळं असणार. ओके. जेवढा कंटेंट कव्हर होईल थर्ड चॅप्टरचा तेवढा असेल आणि सेकंड चॅप्टर पूर्ण. ओके. सो नाउ वी विल स्टॉप ओव्हर हिअर.